Okay, so what we learned yesterday was, guys, when you put a number in for A, all right, what the A value did, the number on top, that was a vertical stretch. Okay, and we discovered that when you have a vertical stretch, that's this right here, when A is bigger than 1, you're going to have a vertical stretch. It does not affect the horizontal, the vertical asymptotes, or the domain and range. Has no effect on them. Okay, when we add a number outside of the function. Okay, now you're going to hear me say inside and outside the function. Let me explain to you what I mean by that. All right, when you're looking at this, here's our mother function on this. Okay. All right, this is the mother function. Okay, now if we had our little function machine here, it's like it goes into this machine. And what this machine does is it takes it and it divides it into 1. Then a number comes out. Okay? All right. If I told you to do this function, like from yesterday, and I asked you, okay, guys, what's the value of this function? You don't need to draw this, just look up here. What's the value of this function when x is equal to 1? So 1 is going to be your input. 1 goes in, it gets divided into 1, all right? Then it comes out, and what happens to it? You add 4 to it. So it goes in, it divides it into 1, then it adds 4, and you get a y value of 5. Okay, if I put 2 in there, if 2 went in, the mother function would divide it into 1, that would be a half, and then you'd add 4, and you'd get 4.5. Okay, so this 4, you do the 4, you add the 4 after it came out of the machine. So I call this outside the function. It's being done after you divide it into 1. Now, if you compare that to this, okay, now what I'm going to do, x, y, okay, now what this one says to do, let's say that x was equal to 1. So put that in there. Pay attention, guys, so you understand this concept here. I'm going to put 1 in. But before I put it into the machine, I'm going to add 4 to it. So really what ends up going into the machine is a 5. Okay, I'm adding 4 before it goes in. So it becomes 5, so outside, it becomes 1/5. Yes, no?
Yes.
1/5. This is being done. You're going to add the 4 to your input, then send it into the machine. So this is being done before the function or inside the function. This is being done after you've already divided it by 1. So it's like this, probably a better terminology would be this is pre-function, and this 4 here is done post-function. First do the division, then add the 4. This one was add the 4, then do the division. That's what I mean by pre-function and post-function. Okay, let's see. Am I online? I'm online. Yeah. Okay. Make sure the people at home. Okay. Questions on pre-function or post-function? Would you please? Okay, so you guys the folks at home, you understand what I mean by pre and post function? Any questions on that? Need me to do another example? Yes, no, no. Anybody else? See, I'm attending to 3 things here simultaneously. Okay, it is. It's like multitasking. Squared. Oh, there she is, live, coming from 618 live.
Dolores.
All right. Okay, so now what we're going to do today is these numbers from yesterday, when I added the 2 and added the 3 and subtracted the 3, we did those post function. Anything that's being done post function has a vertical effect on the graph. Anything that is done pre-function has a horizontal effect. So if we look at what we're doing today now, okay, now we've got, this here. Now instead of adding 2 and something before or after, we're adding it before. So you see right here, this is pre-function. We're going to add the 2 to x, then we're going to divide it into 1. That's different than yesterday where it looked like this. We divide it into 1, then we add it 2. Okay? All right, so let's see what the effect of that is. So if we go to our Desmos graph, okay, and I'm going to take, I got A at 1, B at 1, H at 0, and K at 0. All right. Now, I'm going to take H and I'm going to move it to, what are we looking at? 2. I'm going to go plus 2. Okay, so I'm going to move it to 2. So take the H and move it to 2 and watch how the graph changes. Okay, so when I moved H to 2, the only thing that moved was the vertical asymptote. The whole graph just slid 2 over. Okay, here's the original graph. If you click on this one way up here, that's the mother function. That's where they all started. Okay, now if I take this and I move H, you can compare it to the original. So now I'm going to move H to 2. And there's the new graph. The original graph is the one that's in purple. So all that happened is that everything just slid 2 to the right. Make this dots. Okay. So when I look up here, Control X. Okay, all that happened here, everything just shifted over one spot. Control. Okay, so if you look at this, this was the original point, 1, 1. Okay, and all it did was it moved 4 spaces or 4 over. Remember, each space is 2. So what the effect of this was, it took the 1 and it added, was it, oh, I'm sorry, it added 2, didn't it? Oh, I added, oh, I got confused. Yeah, added 2, right. So this would have been from 1, 1 to 3, 1. It just, all I did was take the x coordinate and add 2. The y coordinate didn't change. The vertical asymptote changed, so that means the domain changed. The domain now is not allowed to be 2. Nothing else changed. All right, so go back to this. Okay, so this is going to be a shift 2 to the right, or I'm sorry, 2 to the left. So remember, the h value in this is actually, hold on. God dang it. It did shift to the right. So for it to shift to the, okay. Right, okay. Yep. That was, knew something was wrong. Oh, thanks. Okay, let's get rid of that. All right, for this to read h or x plus 2, you'd really have to put in a -2 for h. Then you're going to have a negative, which would make it a positive. So I went the wrong way on that, folks. Should have gone that way. That has the effect of moving it 2 to the left. But when you look at the equation, see, that's why we call it bizarro world. When we look at the equation here, it's really the reverse of what you see. Okay, you see +2, but really it's an h is a -2 because of the way that the equation is written. If you put a -2 in there, it's going to change it to a +2. So we called that bizarro world past. Stuff that is pre-function is bizarro world. It's sort of the reverse of what you see. All right, so this guy's going to shift 2 to the left. So that means the vertical asymptote is going to move. So now this is going to be x equals -2. And my domain now is x cannot be -2. So if you have like a highlighter or something, this h value gets repeated there and gets repeated there. And then the y values didn't change. They stayed the same. This is still y equals 0. This is y cannot be 0. Now, yesterday when we wrote out domain and range, we always wrote out this symbol. X is a member of the real numbers, Y is a member. when you write out what I just did there, it's assumed that you mean X is a real number and Y is a member of the real number family. When you write it out like I did right here, the reader assumes that X is a real number. You don't have to write it, is what I'm trying to say. I meant assume, not. Although, you know, I learned, you know where I learned, has anyone told you what happens when you assume? Okay, this is a real true life story. It happened to me in high school and I've never forgot it. Okay, and I hope I don't offend anybody, but so I was in high school and I was playing in a football game, high school football game, varsity football game. And I was playing, I was a DB. That means I was a defensive back. And you're the guys that cover other receivers. So there was a receiver and he ran right there. And this was me right here, skinny me. All right. And the guy went right by me. The quarterback threw him a ball and the guy scored a touchdown. It was humiliating.
You ran out of that.
Okay. So we were playing, I think it was cover 2 at the time. So there's 2 other guys here. There's a guy right here. There's a guy right here. There's another guy like my reflection over there. Well, he yelled at me during halftime. And I made the mistake of saying, Coach, I assumed that the safety was going to cover him. And he goes, Krolak, when you assume, you make a blank out of you and me. Yeah, that was 40 years ago that happened to me. Or no, like 42 years ago. And I still remember it to this day. Some things just stick to you. But so when people on the football team say assume, I say, don't assume. Don't ever assume. I tell them the story. Everyone gets yelled at in football. It's just part of the way the world works. Okay. How did I get on assume? Oh, yeah. Okay. Jeez. I'm like, where was I? All righty. Okay. So this was our original function from yesterday. So this is X, that. This was Y. This was this. Okay. All right, so in this one, if we wanted the X to be a -3 here, what you'd end up really plugging in is +3, exactly. So now if we switch this guy back to 0, and I make H a +3, when I put it into the equation, it's going to look like a -3 because the negative didn't change. So that's the whole reason behind Bizarro World. Okay. So in this case, my H value is +3. So this is going to take the whole graph and it's going to shift it right 3. And then we know these 3 are going to be the same thing. So BA, and then that's the value that's, whoops. Yep, it's supposed to be an X. That's the value that gets kicked out. So X is not allowed to be, I know. You know, oh, never mind. Okay. 3, not 3. not 0, and color code. Okay. All right, now on these next two, now you start getting into multiple transformations. So we're going to hold off on those, and we're just going to practice how to graph slides that go right and left, slides that go up and down, stretches, and flips. Okay, so if you go down to the next page, to these three graphs, okay? All right. All right. So what we're going to do here is graph these. Now, this is real important. When you graph them at home, when you graph them on the test, you won't be using Desmos to graph them or your calculator. You'll be doing them by hand. So this part will always be no calculators, right? And it's really easy to do by hand. It's actually probably faster than trying to type it all in and everything. Come on, computer, catch up. All right. So this first one here is an x minus 5. So remember, the h value is really 5. So when I look at this, okay, I know that a is 1. So there's no stretch going on, no vertical stretching because it's the same as the mother function. Okay, h is 5. Okay, now the effect of that 5, you're going to subtract 5 from x, then you're going to divide it by 1. So this is going to be a horizontal slide, and what would happen here is you would slide or shift 5 right. Now, the way that you shift 5 right is you take the x coordinates of all the points and you add 5 to them. Nothing happens to the y coordinates. All right, so once I have this, then I automatically know my vertical asymptote and my domain. They're going to be the same. So the vertical asymptote is at x equals 5, and the domain x, all numbers except 5. Okay, and then the horizontal is the same as the parent function. So when we're doing the assignment, under each problem you list what the domain and the range are and what the asymptotes are, and then you're going to sketch the graph. Okay, all right. So to sketch this thing, I'm going to draw my asymptotes. So I got my HA, and I should do it as a dotted line. So it helps, like when you're doing these at home, if you use a highlighter for your asymptotes or a colored pencil, something like that. Okay, this is the HA. Okay, and then my VA is over here. Then I label what that is, x equals 0. That's the VA. This is y equals 0. So now all this is, guys, it's like taking the original graph and just sliding it. I'm going to take the original mother function and slide it over. Okay. Questions up to this point. Point. Okay, so Dolores, keep your eyes peeled if anybody's got questions. Okay. All right, so now what you're going to do is graph it. So in our original function, the mother function goes through 1, 1, goes through this point right here, 1, 1, and it goes through negative 1, 1. Oops, let's try that again. Okay, the original one goes through 1, positive 1, negative 1, negative 1. Now all we're going to do is move these points and then use those to graph the equation. Okay, so right down here on my mother function, 1, 1. Okay, and now I just take the x coordinates and I add 5 to them. So this guy is going to turn into 6, 1. This guy is going to turn into 4, 1. And those are my new points. So up here, I'm going to draw 6, 1, 6, 1, and 4, 1. And I use those points to tell me how tight to make my curve. And that's all you need. You don't need to have any more points because remember I said this is a sketch. Okay, now you try to draw a nice smooth curve. Don't make it look like an L. Try to make it like a smooth Zen-like curve. And then you put the dimensions on there. That guy's 6, 1. And this one is 4, negative 1. And then I put that there, 4, negative 1. Without those points, guys, you lose points. You got to be sure that you're labeling. All you need is just one point labeled. Because if those points are right, that shows me that you know how to graph it. Okay? Any questions, folks? All right, now on this next one, the negative 1, guys, remember, it's going to take the graph and it's going to flip it. So we got negative 1 plus 4. The domain is exactly the same as H, except it's the value, you write, it can't be 5. So H, these are all connected. So if H was 0, this would be 0, that would be 0. If H is negative 4, that's negative 4, that's negative 4. That's how you find the domain. These are linked together. So once you know H, you know those others. Okay, so let's take a look at this graph when we flip it. So I'm looking at a 4 and a -1. Okay. All right, so when I make a -1, all it does is it flips this to the second quadrant and the fourth quadrant. It didn't stretch it at all, it just flipped it. And now when I turn H into, I want it to be a +4. So for that minus to become a +4, what's the value of H? Yep, I'd have to make H a -4 so that when I plug it into this form, it becomes a +4. Okay. Oh, moved the wrong guy. And we said -4. Okay, so that's what it's going to end up looking like when we're done. Okay, the whole graph just slid over. All right, so here we got a that's a -1. All right, and what that does is you flip the graph over the x-axis. And the way you flip it is you take the y coordinates and you multiply them by -1. And that flips your graph over the x-axis. Like when we do our anchor points later. All right, H is -4. So my VA is -4, and my domain cannot equal -4. A. Okay, so the transformation that's going to happen here, this is going to slide or shift 4 left. And the way we're going to do that is we're going to take the x coordinates and we're going to subtract 4. Graph those guys. So HA, okay, VA, remember everything that I'm drawing, I'm putting values on so that the person looking at my graph understands what I'm talking about. Now, really what you're doing, guys, you can just do it right on the graph paper too. Okay, I know my original point was at 1, 1. So I can just do it by counting. I'm going to flip it over the y-axis. So now it's right here. And now I'm going to slide it 1, 2, 3, 4 over. And there's my new point. That's going to end up being at -3, -1. Okay, now down here it looks like this. Okay, I took this and I subtracted 4, and I took this guy and I did it by -1. And that's how I got that point. So that tells me this part of the curve okay, now this one used to be at -1, -1. So it flips over, moves up to here, and then I'm moving it 4 places. 1, 2, 3, 4. And it's going to end up at -5, +1. So you can do it just by counting on your picture. Okay, here's the math. Subtract 4, multiply by -1. And sketch away. How about here, guys? Questions on anything I did? All right, last one here. All right, there's 2 things happening here now. You got an A that is a 5. So that's going to be a vertical stretch. And the way you do a vertical stretch is you just take the y coordinates and you multiply them by 5. And that's going to stretch it away from the x-axis. And then I don't have to worry about anything else with it. That doesn't affect anything else. Okay, then I got H, A, D, H, A, and R. Okay, now this is going to be -5. So that's -5. And this can't be -5. Whoops. Y equals 0. And our transformation is a shift 5 left. And we're going to do that by taking the x coordinates and sliding them 5 left. So you can just do that right on your graph and you're going to have your 2 points. Okay, so here's what I mean. This is the point 1, 1. So in my head, I'm thinking 1, 1. I'm going to take that and multiply it by 5. So it just got stretched up to 1, 5. And now I'm going to take it and I'm going to slide it 5 left. 1, 2, 3, 4, 5. It's going to land right there. That's my new point. It's going to be at -4, +5. So I'm just doing it by counting and stretching. Okay, here's the other original. Okay, so in my head, I'm going to stretch it by a factor of 5. So I'm thinking, take the y coordinate, Krolak, and multiply it by 5. It's going to now be here at -1, -5. That's a stretch, and now I'm going to slide it 4 left. 1, 2, 3, 4. And it's at the point.
Yeah, it should be
Oh.
5 left.
Oh, did I miss one? Yeah, it should be, I stopped early. So that should be at -6, -5. Okay, and then you just throw in your asymptotes. So that was my vertical. X equals -5. Horizontal. Y equals 0. And now that tells me how to draw my graph. All right. We'll stop there for today. Tomorrow we'll do the other one. So no assignment yet. We haven't got through all the notes just yet. 1, 1, -1.